This is objective 5.2, where we are calculating the distance between two coordinates, okay? So we'll start with vocab. So this is going to involve right triangles, which are triangles with a right angle. Yep, you should be copying this down. Okay, and when we have a right triangle, it's important that we differentiate between the hypotenuse and the leg. The hypotenuse is the longest side, which will always be across from that right angle. The legs are the other two sides. Okay. And then when we are dealing with triangles, especially right triangles, we can use Pythagorean theorem to solve for missing sides. And then today's lesson, we're going to use ordered pairs. An ordered pair is an x and a y value paired together when we're on a coordinate plane, right? So we're on an x-axis and a y-axis. And then it's a way to name that spot that's like a horizontal and vertical, like kind of distance from the middle. And then this lesson is all about finding the distance between two coordinates. And distance is just the space between 2 points. Okay, flip to page 2 when you've got this down. Okay, and so in class we just kind of talked about like how distance, it can be useful to find the distance between 2 points, especially if you're trying to find the shortest distance between 2 points. Okay, we're going to skip over that and just come straight to our key points box, okay? Where we're going to talk about like something called the distance formula. The distance formula is an application of the Pythagorean theorem that can be used to find the distance between 2 points. Okay. So before I get into Pythagorean theorem, I want to show you how I can use distance, or how I can use the Pythagorean theorem to find the distance between 2 points. All right, so we're finding the length of AC, right? In this example, y'all see AC here, right? And if I want to know the distance from A to C, right? Now, in some cases, we could just count boxes, right? But counting boxes doesn't work in this example because it's diagonal, right? But here's the thing. If I make AC into a right triangle, where I think about the horizontal distance from A to C, right? And if I count, how far is it from A to C? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 units horizontally between A to C. And then vertically from A to C, how far is it? So from A to get up to C, that's 1, 2, 3, 4, 5, 6, 7, 8 units. Y'all see what gets formed there is a right triangle. Y'all see that? Yeah? So as soon as I have that right triangle, then I can just do A squared plus B squared equals C squared and think about this distance between A to C as the hypotenuse of my right triangle. So I'm just going to do 8 squared plus 15 squared equals C squared. That's 64 plus 225 equaling C squared. The sum of 64 plus 225 is 69? Yep. No, 289 equals C squared. Square root of that is going to be 17. So the distance from A to C is 17. Okay. We good on that example? Yeah? Okay. So now example 2, same sort of question. We got N to O, which is a diagonal segment, right? Now, again, so I can't count boxes because it's diagonal, but what I can do is create a right triangle out of this situation, right? Where again, if I think about the vertical distance from N to O is 1, 2, 3, 4, 5 boxes. And then the horizontal distance between the two is this segment. 1, 2, 3, 4, 5, 6, 7, 8. Sorry, I'm going to count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 boxes. And again, I've created a right triangle, right? I did that. So now my legs of my right triangle are 5 and 12. So I can do 5 squared plus 12 squared is equal to c squared, which would be n out. Okay. So then 25 plus 144 equals c squared. I get 169 equals c squared. Take the square root, and c is going to equal 13. Now see that? Okay. So example 3 is different. It says find the distance between 3, 2 and 7, 8, but I don't have a picture, right? So now I'm going to show you kind of how you could like sort of think of like a formula to figure that out. So what I can do is, well, here, I'm going to sketch first out what this looks like. So 3, 2 is at like 3, 2. 7, 8 is like 3, 4, 5, 6, 7. 3, 4, 5, 6, 7, 8. So 7, 8. This is the segment. So I've just kind of visualized where these coordinates would be on a coordinate plane. Yeah? We see how it creates a diagonal segment, right? And so here's the thing. Again, if I do the thing where if I create a right triangle, right, then I can do Pythagorean theorem. But it's kind of hard to count with this sketch, count the boxes. So instead of counting the boxes, here's what I can do. I'm going to go up to this picture, okay? So anytime we've got like a diagonal segment, right? Again, we're creating this right triangle. And we want to know how long this leg is. Well, how I find this leg is at, the horizontal leg is, how I can figure out the distance between these two is use the x coordinates, right? So this is at x2, right? As I go over here, we're at x1 on the coordinate plane. Right? I'm just using x2 and x1 to talk about different coordinates. Like, you're going to start using variables. So how do I find the space between x2 and x1? I just subtract and then take the absolute value of that. Does that make sense? So whatever x2 is, if I subtract from it whatever x1 is, it's going to tell me how long this leg is. Now let's think about the other leg. If I have the other leg, now that's the distance between the y coordinates. So we're thinking about how high up are we on the y coordinates from here to here. So that's, well, y1 minus y2. And I'm using the ones and the twos here just to talk about two different points. And then I'm going to take the absolute value. Then, once I know these values, I can then use the Pythagorean theorem where I can think, okay, c squared is equal to a squared plus b squared. Where now I'm thinking of a as x squared minus, or x2 minus x1 squared plus y1 minus y2 squared. And now that is going to be equal to c squared. I want just c, or we call it d, so then I can take the square root. So that's the distance formula. It's just the application of the Pythagorean theorem. Okay? So then, for this example, if again I'm trying to find this horizontal length, I got to think about the space between 3 and 7. Right? So I'm going to rewrite these coordinates. 3, 7. Or if I could even think of this as like 3 and 7, that's like 3 and 7, right? What's the distance there? I could do 7 minus 3 and get 4. Or I could do like 3 minus 7 and get 4. Okay? So the space between these two is 4. Now if I think about the space between 2 and 8, what's the space between 2 and 8? It's 6. If I'm at 8 and then 2, 8 minus 2 is 6. Okay? Or sometimes I'm seeing people that like to stack the coordinates and do 8 minus 2 and get 6. So why did I do all of that? To show you that now I can do, those are the legs of my triangle, 4 and 6. So now I can do 4 squared plus 6 squared equals c squared. I can get 16 plus 36 equals c squared. That's 52 equals c squared. Now, I do want to remind you that when I go to take this square root, let's leave our answer exact. So I'm just going to rewrite the square root of 52 over here. And I'm going to rewrite it as the square root of 4 times the square root of 13. And that's going to allow me to write it as 2 square roots of 13. That's the exact answer. We could change this to a decimal as well. Okay? Hope that all made sense. Have a good rest of your day.